So you're running a traditional data center network. You know the deal. It can be rigid, complex, a real headache sometimes. The big question is always, how do you get to something modern, something automated, like Cisco's ACI, without, breaking everything? Well, in this explainer, we are going to walk through the exact step-by-step methodology for doing just that. We're talking about moving from your existing brownfield network to a brand new greenfield ACI fabric, and we're going to do it while keeping the lights on.
All right, so here's our game plan. We'll start with the big picture, the whole migration journey. Then we'll zoom in on the core steps, kicking things off with design and deployment, then bridging the old and new networks, moving your actual workloads, that all-important step of shifting the default gateway, and finally, we'll wrap up with the cleanup and optimization phase. Let's get into it. Okay, first things first, let's get our terminology straight. You're going to hear these two terms a lot. Brownfield, that's your current network, the one that's up and running right now, doing its thing. Greenfield, that's the shiny new Cisco ACI fabric we're about to build. The whole strategy, the magic of it, is all about building a bridge between these two worlds so we can have a really smooth transition, without giving anyone a heart attack.
When you boil it all down, the entire migration really comes down to these three simple phases. First, you deploy. You get that new ACI fabric up and running. Second, you integrate. You connect it to your existing network. And third, you migrate. You start moving your applications and workloads over. It sounds simple, right? But trust me, the secret sauce, the key to success, is all in how you execute each and every one of these steps. All right, Section 1, the ACI migration journey. Okay, moving on to Section 2, deployment and design. And I gotta say, this is arguably the most critical phase of all. Seriously, the decisions you make right here, right now, are gonna define how your new network operates for years to come. So careful planning, well, it's everything. So a solid plan always starts with a checklist, something just like this. You've got the physical stuff, right? Picking your switches, your controllers, getting that initial setup done. But the real heart of the design is in these logical constructs. This is where the magic happens. You're figuring out how to map your old school VLANs into ACI's bridge domains, or BDs. You're planning how you'll use VRFs for network segmentation. And most importantly, you're defining your endpoint groups, your EPGs. And these are the absolute cornerstone of ACI's whole security policy model. And this slide just drives home a super important point. Before you can even think about building that new greenfield fabric, you need a perfect, detailed map of your current brownfield world. I mean, you have to document everything, every single VLAN, every subnet, every default gateway. And that goes for your virtual environment too. You absolutely have to know exactly how your VMware distributed switches are configured, because we're going to be plugging ACI directly into that world. All right, let's jump into the next step, where we actually build the bridge, both physically and logically, between our brownfield and greenfield worlds. So the big question is, how do we physically connect these two totally different networks? Well, the most common, and frankly the most robust way to do it, is to build a high-speed Layer 2 link between them. If you look at the diagram, you can see what's happening. We're connecting our legacy core switches to a pair of ACI leaf switches. Now, the real key here is using a technology like a double-sided virtual port channel, or VPC. What that does is it creates a single, logical link that's not only super high bandwidth, but, and this is crucial, it's completely free of network loops. That's what lets us safely stretch our VLANs from the old network right into the new ACI fabric. Okay, with that physical link in place, the path is now clear. We can begin the most active phase of this whole project, the methodical migration of our application workloads into their shiny new ACI home. So once you're connected, you come to a fork in the road. You've got a fundamental choice to make. On the left, you've got the network-centric approach. This is the simplest path forward. You basically just recreate your existing VLANs one for one inside of ACI. It's fast, it's easy, it gets the job done. But on the right, you have the application-centric approach. And this is where ACI really starts to shine. Here, you're not thinking in VLANs anymore. You're grouping endpoints by their role. These are my web servers, these are my database servers. And that lets you build incredibly powerful security policies between them. It definitely takes more planning, but this is what unlocks true microsegmentation. So here's a quick look at that network-centric model in action. See? It's super straightforward. VLAN 10 from your old world gets mapped to a new EPG, we'll call it EPG VLAN 10, and that lives in its own bridge domain. Lather, rinse, repeat for VLAN 20. It is a direct one-to-one translation, which is exactly why it's such a popular and easy starting point for so many migrations. Okay, stop and listen because this is absolutely critical. During the migration, your VLAN is literally stretched across two different networks. You've got some servers in ACI and some that are still on the old gear. Now, ACI by default is designed to be super efficient. It hates flooding traffic everywhere. But in this temporary mixed state, that efficiency can actually break things. So to keep communication flowing, you have to temporarily tweak the ACI bridge domain to flood unknown traffic and ARP requests. This is the magic trick that makes sure servers in the old network and servers in ACI can still find and talk to each other.
Okay, now let's flip over to the application-centric model. All the servers, they're still in the same subnet, right? They're all mapped to a single bridge domain. But look what we've done inside ACI. We've logically separated them into different EPGs. So now, even though they're on the same network, we can use ACI contracts to get super granular. We can say, hey, only the web servers are allowed to talk to the database servers and nothing else. That is microsegmentation in action.
This brings up a good point. In that app-centric model, EPGs are totally isolated by default, so you need a plan to keep things talking during the migration itself. You could set the whole VRF to unenforced mode, but that's like using a sledgehammer to crack a nut. Not recommended. A better option is to temporarily use something called a vZANI contract, which basically says, let all traffic through for now. But honestly, the best, most flexible way to do it is using the preferred group member setting. This lets all the EPGs talk freely, and then you can pull them out of the group one by one to apply your specific, strict contracts when you're ready. And now, we've arrived at one of the most pivotal moments in the entire migration. This is the big one, moving the default gateway for your subnets from the legacy network into the ACI fabric. This is the moment ACI officially takes over as the router.
So, in the beginning, the default gateways for all your subnets, they're still living on your legacy network. ACI at this point is basically acting like a giant fancy layer 2 switch. And to make sure it stays that way, that unicast routing setting inside the ACI bridge domains is turned off. It's ACI's way of saying, hey, I'm not the router for this network. Not yet, anyway. But this creates a bit of a puzzle, right? What happens when you move the gateway for one subnet into ACI, but all the others are still being routed on the old network? How do they talk? To solve that, we build what's called a Layer 3 routed connection, or an L3 out, between the two. We'll run a routing protocol, something like OSPF, over this link. That way, ACI and the legacy network can exchange routes, making sure that everybody can talk to everybody else no matter where their gateway lives during the transition. So after the cutover, the whole configuration gets flipped on its head. The gateway IP address is moved over to the ACI bridge domain, and we flip that unicast routing switch to on. This activates what's called the pervasive gateway, and this is so cool. Think of it like an Anycast gateway. The exact same gateway IP and MAC address exist on every single leaf switch at the exact same time. What this means is that traffic doesn't have to schlep all the way to some central router anymore. It gets routed at the closest possible point, which is just fantastic for performance and for resiliency. The actual cutover, it's like a carefully choreographed dance. To make it totally seamless for the servers, here's what you do. First, you go grab the virtual MAC address that HSRP is using on your old router. Then, in a very quick sequence, you configure the IP and that same MAC address on the ACI bridge domain. Then, you disable the old L3 interface, and finally, you enable unicast routing in ACI. It's this precise sequence that minimizes downtime, because the servers don't even realize the gateway moved. They never even have to update their ARB caches. All right, so all the workloads and all the gateways have been successfully moved into ACI. The heavy lifting is officially done. Now it's time for the final phase, cleaning up our temporary configurations and really optimizing the fabric for performance. Hey, remember those bridge domain settings we had to change way back at the beginning? Well, now that every single endpoint is connected directly to ACI, we can finally switch them back to their super optimized default settings. We'll change unknown unicast from flood back to hardware proxy, which lets the fabric intelligently forward traffic instead of just blasting it everywhere. We'll disable ARC flooding to cut down on all that broadcast noise, and we'll turn on limit IP learning to subnet, which is a great little security feature. Just a heads up, you'll want to do these changes in a maintenance window, as they can cause a tiny blip in service. Okay, let's switch gears for a moment and talk about a special case, virtual workloads. When you're migrating virtual machines, especially in a VMware vSphere environment, there are a few specific tricks and methods you need to keep in mind. With VMs, the name of the game is always a zero downtime migration, right? We want to use vMotion, and you've really got two main ways to pull this off. Method 1 is the most straightforward. You just extend your existing VMware distributed switch over to the new hosts that are plugged into ACI. Simple.
But method 2, which is really the recommended and way more powerful approach, is to use ACI's Virtual Machine Manager, or VMM, integration. This is where ACI talks directly to your vCenter to automatically create port groups that map directly to your security EPGs. It beautifully integrates your physical and your virtual networking worlds.
And that, my friends, brings us to the end of our migration journey. But in a lot of ways, this is just the beginning. The migration itself, that's just the act of moving into a new house. The real, truly transformative power of ACI comes next. It comes when you start defining those granular contracts between your EPGs, when you build a true zero-trust security model, and when you really start optimizing your data center for the applications it runs. The foundation has been laid. Now it's time to build the future on top of it.